biggest mistake developers make when building AI apps is letting LLMs do too much. Most developers are stuck choosing between rigid code that can't handle natural language inputs or unpredictable AI that occasionally breaks your entire system. But here's what the top 1% of AI engineers know. You don't have to make this trade-off. The secret isn't choosing between LLMs and traditional code, it's using what I call an LLM router that leverages the strengths of both. In the next 5 minutes, I'll show you how to build an LLM router that gives you both the flexibility of AI along with the reliability of code. This is the exact approach that's powering real AI systems that never seem to break in production, even with unpredictable user inputs. After watching this, you'll never build AI apps the same way again. This is a dummy project I made called the MCP Quickstarter. The concept is an AI-powered command line tool designed to help developers rapidly create, configure, and document new MCP servers. I'm not going to get into MCP servers, but if you want a tutorial on that, let me know in the comments on what you'd like to see. The core idea here is instead of users needing to know specific commands, what if they could just tell the application what they want to do in plain English and let the application figure out the right piece of code to run? I'll walk through the single Python file explaining the principles and concepts for an LLM router, followed by a short demo to show it in action. So I've made these 4 mock functions for different aspects of the MCP development lifecycle. For this demo, they just print messages, but in a real application, these would be doing the work, setting up project files, writing code, configuring security, etc. Each one represents a distinct capability of our assistant, and because the functionality is written in code, it will reliably execute the same way every time. Sitting between the user and these functions is the LLM. The LLM will take the user input, and by leveraging function calling, it will route the user's request to the proper function. This is how we can take any user input and fuzzy match it to deterministic code. To let the LLM know which functions are available, you make a list of dictionaries to describe the functions of their parameters. The description is key. It tells the LLM what the function does and, crucially, when it should be chosen. Sometimes these function names don't match what's in your code because readability for humans and readability for AI are not the same. So a function map is vital. When a user enters their input, we send it to the LLM for a decision on which function to use. We enhance the prompt for our use case and include any available functions and any parameters that we want to set. The LLM will then match the user's request to the most relevant tool description and figure out any arguments needed. The code to handle the response will vary depending on which LLM provider you use. You simply parse the response and then you call the selected function with any arguments. And that's all it takes to make an LLM router. But what if the LLM gets it wrong? This is where evals, prompt engineering, and fallback mechanisms come into play, but we'll cover that in another video. Now, let's see it in action. Okay, let's say I want to build an MCP server for interacting with Twitter. I want to make a Twitter MCP server. Nailed it. The LLM decided that define MCP tool was the right function. It likely picked up on make and Twitter MCP server and then matched it to the function's description. It also figured out an idea for a tool idea. Now that I've got the initial idea down for my Twitter server, I need to set up the project environment, and let's just stick with using Python. Okay, I've got some ideas for my Twitter tools. Now, how do I actually set up the Python project files and environment for this MCP server? The LLM understood I'm asking about project setup, and specifically for Python. It routed us to set a project environment and pulled out Python as a language. That is because the function description talks about handling project setup and language choice. Let's say one of the tools I defined was post tweet. Now I need to write the code that actually makes the Twitter API call for this post tweet tool. I've defined a tool called post tweet that should take some text. What's the next step to actually write the code that connects to Twitter and makes the post happen when this tool is called? Perfect. The LLM identified that I'm talking about implementing the logic for a specific tool, post tweet, in a service Twitter. It correctly chose implement external API and extracted both the tool name and the service name. Of course, my service is going to need API keys. To actually post to Twitter, my server will need my API keys. How do I handle those securely within the MCP server so it can authenticate correctly? Once again, the LLM understood that API keys securely and authenticate point towards needing configure server auth for the Twitter service. It's important to remember that the LLM isn't just doing keyword matching, it's understanding the intent and extracting relevant details from the user's request. LLM routers get you the best of both worlds. AI is a fuzzy function and reliable code consistency. In modern apps, users don't want to learn a rigid set of commands. They just describe what they want. Natural language is now the default for how people interact with computers. I hope this helped the way you think about building AI apps. I'd love to know what you're building, so please let me know down below. To help me out, please send this to your vibe coding friends so they can make better apps. And if you want to see more AI tutorials, please subscribe. Thank you very much.